again. That's why it's always good to see that it works. So, yeah, it's running. Okay. So back to this. Karoche, we're gonna talk about synths. Hey, that's such a stupid meme I saw last year, and now here we are. Okay. So book 1, book 2, and set of articles and sound of sound. That's what I wanted to open now to show you when Vera came to tell us this. So this is Sound on Sound. If you don't know, this is an incredible magazine for audio engineers, musicians, everything. And this is a whole series of articles. You see, like, tuk, 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 it keeps going. It's just like infinite amount of articles called Synth Secrets. So this is just carries on. Like, I mean, it goes all the way to what? To, well, it's not so much, but I guess like 40 or 50 or something. So yeah, these are just things connected with somehow with synthesizers in general, and I just wanted to put it there if you want to expand. Or if you want to tell ChatGPT to write you a summary of what everything it says there, you can feed it into it, and that's it. So what's going to happen next in our course? We're going to continue our synth explorations. We're going to continue our, I just wanted to give you an orientation, continue our styles and genres discussions that I've been doing with the DPO and with you too. So we will do hip hop, obviously, that's why I was asking, and this presentation is already done. We will do Latin. The Latin is amazing one, I already gave it. And we will do abstract and ambient and electronic music too. We will discuss arrangement instrumentations. We will do a studio practice. And I wanted to let you know, so you can start preparing in your heads for this, that we're going to have something called the Synth Challenge. So I'm going to give you a sound, like a barking dog, like a real life sound. And you have to recreate it with a synth somehow. Whatever, or whatever, I don't know, like a train or a sound. It's not going to be a music. It's not going to be music, just a sound. And the next thing I'm going to give you is, like, I'm going to ask you to recreate a song from a selection. So I'm going to give you a selection of songs that are synth-based, and then you'll have to make a recreation of this song in the best of your abilities. And I want to tell you the end of semester task. So you know already kind of, it's really much in advance, but it's a big task. So I want you to know in advance very much. If this thing loads, I hope, when soon you're going to get this, like a Google Classroom invitation, which is like, hey, look, there are these songs here, and then I'm going to randomly administer these songs, and it's like, you have to do this, 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 and you'll have to make a copy of the song with synths. So as better as you can. Like, they are really hard. You're not going to be able to do it. My expectation is something like this, kind of, so it's going to be fine. It really doesn't matter if it's not like the best thing in the world. I just want you to practice, like, okay, like, this is kind of how it works, and that sounds cool. No, in whatever, if you have amazing scenes and that studio that you show me, you can go there and redo it there, no problem. Like, it just however you want. End of the year task is going to be to create a fresh, shiny, new 4-song release. So that's why I'm telling you in advance. Like, I want you to, at the end of the year, to give me an EP, very little. Like, the songs can be 1 minute. Like, I mean, they can even be 1 minute. It's okay. Like, I'm not going to push you so much, but I want you to know that we will have to make an EP for the end of the year. And I mean I mean that it's not, you cannot just like grab your EP that you made 4 years ago and just give it to me. Like, it has to be really that you made it for this. And from that release that you're going to do, we will choose one single. I mean, everybody will give me 4 songs and will tell me, this is my single. And that single, we will put it in the compilation for the year, you know, like we do every year. And all right, so just wanted to give you a bit of a overview of what's coming next in the course and what we're going to do, okay? We stopped last week in the 70s. Like, that's where the last thing we did, we watched Bob Moog talking to us about the Moog synthesizer. And where I wanted to go was to the 70s. We discussed already, like, the release of the Mini Moog Model D and the ARP 2600. We discussed the 70s already. I'm just going through a recap. We discussed monophonic synths. Synths that can play only one note at the same time, polyphonic synths that can play more than one note at the same time, and that's pretty cool. And we started talking about the Mini Moog. In general, we saw it from inside. We discussed that, hey, this is like how the circuitry looks inside. And we saw this kind of couple of videos with Robert Moog and a bit of the history of the Mini Moog. And
the father of the modern.
Really nice. And this is where I wanted to arrive today. So let me look at something in my presentation flow here, because I'm very busy right now, and I may have. Yeah, I think I want to see this slide a little bit later. We're gonna see it just a little bit later. I think it's gonna be more cool if we discuss a couple of historical things and then we come to this. Sorry for that. I guess that I'm gonna put it here. Yeah, yeah, here is great. Okay, sorry. So continuing a little bit the history lesson that we're discussing, so you understand like a little bit of the, I don't know, of the consequences of synths. Like, I want to ask kind of like more you ladies, because I know that these guys know a bit more about synths and stuff, and I just wanted to ask you like, I'm really curious, like you, because we're a bit of a different generations, and I'm a bit older, and I just don't see the life from the same perspective as you. Like, do you see all these machines and like the synths and stuff, and what is your relationship with these things? Like, do they form a part of your culture? Do they not form a part of your culture? I hope you understand my question, if you can help me a bit. Do you have a relationship with synths? Like, do you understand them? Do you like them? Do you understand the potential that you can do with this, the power of it? Or do you see it as something there that it's like, for example, let me tell you what I mean. When I think about a balalaika, I don't feel that this is something that belongs to me as a musician. But when I think about a synth, I think like that I can do everything with it. What do you feel about a synth? Do you see it as something far away from you, or do you see it as something close from you? You don't use much synths? Mm-hmm. Yes. But you see, an instrument, a synth is an instrument. That's exactly what I wanted to ask the question. I wanted to get somewhere kind of there. A synth is just as much as an instrument as a guitar. I'm not trying to contradict you at all. I'm just showing you how I feel it. It's not to tell you, hey, you're wrong, I'm right. It's just like, hey, look, that's how I feel it. I don't see a difference between balalaika and a synth. Like, the difference is that with a synth I can do more stuff. But how do you feel about synths? Do you have a relationship with them? Понятно. Очень далекие. Ага. И у тебя? In your case? Okay, cool. You will. The future, I hope you will. And what about you guys? Like, how? I mean, I understand you two guys like feel it close to you. It's part of your culture, your life. You see it like as something that you can grab and do something with, right? Or it's very advanced type of voice. Yeah, it's very advanced type of voice, and I really like that you said that. The reason why I'm saying this is because I don't like that I wish that we don't lose the capacity to get surprised about things. Like, oh my God, like look at this, like this device, like, and also that we don't forget that the history that we're living is so. Like most of the things we're living are so new, like so fucking new. Like I mean, in the 70s, somebody came like, just like I'm right now talking about ChatGPT. Somebody was like, man, look at this machine; it can make any sound in the world, and these are profound transformational realities. That's kind of where I want to try to bring you to, so you understand the dimension of what we're talking about. It's not just some machine there that was there. Imagine that I go back in time and I tell to Louis the XV, you know, whatever, the King of France, like, I have a machine that can make any sound in the world, and he would be like, you're going to prison right now, like you're a witch, you're gonna die. And I just want you to remember that when these things came out, this was really like pioneering, and everybody was like, fuck, the future of music is gonna be so different. And it wasn't, and it was at the same time. Like, this is an interesting conversation. What about you guys, like, in your relationship with synths? Like, let's start with Anton. Uh-huh. You have been 3 years playing with synths, kind of, like, yeah. Mm-hmm. You were surprised, right? Okay. Да. Да. Great. Yeah, awesome. And that's yeah, we were talking about this yesterday, right? Like yeah. And what about yourself, Radan? Like sure, sure, sure. Presets or things like that. Yeah. Okay, cool. Uh-huh, uh-huh, uh-huh. This is really cool. This is really cool. Murad is really good at this. Yeah. Murad, yeah, yeah, we played a lot with this last year. Like, yeah, that's really cool. And what about yourself? Well, I know also that we have been talking about this. You're excited about this, so you want to get there, right? Want to understand them, and we all. I mean, the point is that. Sorry that I don't give you the word. It's just like we just talked about it. And if you want to say something different, yeah. No, I mean we have been exchanging videos on Telegram like about the scenes like that, how much he likes like music created with synths and stuff. And of course, look, so you know where we should be in a couple of years, not now. Um, I just made the movie, right? I have been boring you with all this, like talking about the movie every time, and I use presets all the time. It's not because I don't know how to build sounds. It's because I'm too slow at making the sounds as well. I'm not so fast, and so it's faster for me to use presets. What do I mean by using presets? You know, when you open the synth and just like I want to load this sound. But a synth is not supposed to be like that. A synth is more supposed to be like, I'm a blank page, do whatever you want with me, and then you just dial it up until it makes the sound that you want. And that would have made an even more original movie than what it is, what we did, because it's so funny. Now that I've been so much into this world of writing film soundtracks and stuff, and I learned all the patches and all the presets because I had to study them all when I was building this soundtrack. Now when I watch movies, I'm like, that's contact, you know, contact damage preset number 25. Like, so, I mean, ideally, we should create our sounds so we can just morph it and propose to the world new sounds, unique sounds. Okay, so I made this little pause so we do not forget, because I mean, my problem with the world is that I think that people become very cynical very fast, and we shouldn't forget that these technologies, when they came out, were really revolutionary, and they still are. Like, I always joke about this. Imagine that I tell you I met an alien that gave me a machine that can create every sound in the world. And you would be like, holy shit, show me that machine right now. But if I tell you, Liana gave me a machine that can make all the sound in the world, you're like, "Ah, whatever." It's like, why? Why the alien part makes it more interesting? Like, if the machine is the same. It's like, but anyways, I would also be excited about the alien. So, okay. When the 60s ended, what happened before the 60s, and what you need to understand is that all of this, let's say, these first proto synths that we have discussed so far, the Moog Modular and the Mini Moog, and this kind of like huge, and also we talk about the ARP 2600, they are analog synthesizers. They have electronic components inside, but they don't have a computer inside. It's kind of more like, imagine a game of a labyrinth that moves electricity in a way that produces sound. But it's not like a computer that has a program which you can change the program and say like, okay, like every 2 seconds, do this beep, 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 whatever. Like it's not like that. It's more like it's closer to a light bulb or to some like kind of electronic device than a computer. You feel me what I mean there, right? Okay. And that's what started changing in the 70s. Because the microprocessor became a really accessible and cheap and possible thing to use. And so it's like, hey, why don't we put a computer inside this machine that can generate sounds? It's like, okay, sounds like a good idea. So by the late 70s, the microprocessor became really available, and this became more affordable and possible to produce. And so that meant that you could now shrink all these, make microscopic versions of all these components, so you can put many synths together in one. And what do I mean by this? Because you could ask me, Leo, why there were ever monophonic synths? Like, why would you want to make a synth that makes only one sound? Like, why don't you make a synth right away that makes a lot of sounds, and that would be cool? But the technology was not there. That's what I'm trying to tell you. So all of these synths that you see, the huge Mini Moog and everything, they can only produce one voice at the same time because the components were so big that you couldn't make a synth that could play two voices at the same time. But when the microprocessor became readily available, it's like, okay, let's do this. Let's grab one synth and shrink it into this thing that looks like this. I mean, or maybe like this. And let's put two of them together, and now we can play two voices. Hurrah! So we can have a polyphonic synth. So that's why we came out of the 70s from monophonic world into the, out of the 70s from monophonic world into the 80s to polyphonic world. Because with monophonic synths, yes. Yes, correct, yeah. No, the work of Switched-on Bach is crazy, exactly. And that's precisely I hope, the type of excitement that I wish you never lose. You see, like, he thought about it and he was like, fuck, that must be so hard. Like, how can I do this? Like, and I want to be a bridge in between other generations and things like this, because this story is amazing. It's really amazing. It's huge. Like, if you don't get excited about it, then change the human for an alien. Just remember about that, and you will always get excited. So anyways, a great example of this was a very cool synth that came out in this time that is called the Sequential Circuits Prophet 5. And this was a really yes, and it's amazing. It's amazing synth. It's a really cool synth. I had a very funny, stupid story with the Prophet 5. The keyboard player of Zemfirы had a Prophet 5, and when we were in Dubai, we were just saying like, man, pass me on the Prophet, like grab the Prophet and throw it there and stuff. And some guys came to us and told us like, please don't talk about the Prophet like that. And they were really thinking that we're talking about Muhammad or something. And it was just a stupid, funny anecdote that happened to me in some musical situation. So anyways, okay. This was the first affordable, programmable polyphonic synth. And what do I mean by programmable? That you can switch it off, switch it on, and click a button, and it reloads the same sound that it was before. Like before of that, it was more like, I have this knob goes here. If I move it like this, how do I save a sound? I take a photo, well, whatever. There was not like a digital camera back then, so I just write down in a paper, like, okay, this is where this knob was, this is where this knob was. Yeah, or they are preset sheets. Exactly. Sheets, MOOC, like, or there were things like this, if you wanted to save a sound, like, I guess, yeah. I guess something like this. Well, I don't know where we're gonna find it, but yeah, there's gonna be one. It's really easy to find. There were this, this one is a good one. Like, but this is a flotation tank, by the way. Ah, no, sorry, I see, it's a synth called. Yeah, these are the preset sheets. So check. So then you can write like, oh, this sound is so fire. Take this to the archive, close, and that's how you save presets. But yeah, long story short is that these developments in technology were really important. And around this era as well, like, early synthesizers were monophonic, meaning they could play only one note at the same time. And some of the earliest commercial polyphonic synthesizers that came out were created by a guy called Tom Overheim. And this is a very famous synth called the OBX7. And then in the 70s, there was a company called Sequential Circuits that made the Prophet 5, and it's amazing. I use the Prophet 5 all the time. It's really cool. And you see, like the Prophet 5 used microprocessors. So before, again, we had an analog synth that was just like a labyrinth of electricity that produces sound, and now we have a computer there. And if you don't feel the difference, it's because you don't understand computers so well, but this is a very deep change on how we make music. And obviously, just like we discussed in the whole topic of history of music production and all of that at the beginning, the kind of technology that you had available absolutely changes the type of music you make. So who knows what music we're going to be making in 10 years, considering all the things that are happening right now. It's going to be crazy. So, yeah, and I mean, this overcame a major difficulty for previous synthesizers, which required to save all these knobs and caves, and you couldn't recreate the same sound. And this facilitation the move from synthesizers creating unpredictable sounds to producing a standard package of familiar sounds. So this was a big deal in the history of synths. So this brings us to the 80s. Yeah, when you can presets, you can experiment more because you can save them, you can go back to them, you can load them, etc. And that's really cool. So then we arrive to the 80s. So in the 80s, we already have like super amazing, powerful supercomputers, like that. I don't know. You know that your phone's computer is like 10 times more powerful. No, not 10 times, maybe a million times more powerful than the computer that took the astronauts to the moon, for example. Like, yeah, and so I'm just kidding that, yeah, in the 80s we had already super amazing computers, like, I don't know, that could use a floppy disk or something, but anyways, it's really, really great stuff, and this allowed people to do awesome equipment. So we discussed already the overtime, and then some other new technologies started appearing, some things like wavetable. We will discuss this later. We will not read any this right now. Around the 80s, Yamaha introduced the iconic DX7, and this introduced a new method of synthesizer called linear FM, and by the late 80s, we started working in something called the pulse code modulation. Like, this is an overview, and we're going to be seeing these things with calmness in these lectures. Like, I mean, what is this wavetable thing? How does the DX7 sounds? Like, I want you to have a paliter, you know, of capacity of understand, like, oh, this synth sounds like that, this synth sounds like that, so you can actually start imagining some different sounds and how to use this instrument. So I wanted to show you a little bit some of those guys. This is the OBX, the Overham OBX. I wanted to also show you a little bit about the Yamaha DX7. This is very famous synth, and it's really amazing. And just showing it to you inside, I mean, it looks like a computer kind of thing. And this is, well, one of the most amazing synths ever. Like, the film that I made, the film that I made, yeah, it's made mostly with the Fairlight CMI. It's really amazing. It's really cool, powerful synth. And yeah, we discussed this, like, did I show you the website where they were selling it? I think, did I show you that or not? It was like $12,000. I found it, like, I found the one that the composer of Terminator used. I mean, the one that he used. Anyways, the Synclaver, it's really amazing synth too. The Ensoniq ESQ1, it's really cool synth. Well, and the CS82 is an important synth too as well, that it skipped my list. And then we have the Roland D50, the EMU SP1200, the Korg M1. Like, I mean, I put these photos here and these synths here, so you go on your own and just go and check them out, I mean, if you're interested. Like, and you know that they're there, you know. And then in the 80s, somebody released something that kind of made a very big deal, which is the IK MPC, which it's not a synth, but was allowed. I mean, it arrived to us thanks to the developments of technologies that happened around the synth. And this was a major big deal because this was a sampler that allowed musicians to sample any instrument and sound. And this became the base of a new upcoming genre that I think became popular after that, which was hip hop. I mean, so you see, like, all these technologies allow us to make music that was not possible to be made before. And if we're going to talk about synths and samplers and machines, we have to remember that thanks to them, we can start doing different music like hip hop. So if you look inside a synth, I mean, I just like to show you these things so you can have a feeling of how something like this looks like. This is an interesting conversation. Like, I mean, I love this kind of projects. This is a Juno 6. It's very similar to this one. It's like it's a bit older, yes. And you see, right now, you guys are used to that all of these devices have a USB cable that you connect into your computer, and then it works on the computer. Before that, there was another way of interacting in between synths and other things, which is called MIDI, right? Like, we will discuss this a little bit later in our course. But before MIDI, there was another protocol called voltage control. It was like the older one. Yeah, control voltage, CV. And so you will connect, it kind of looks like a guitar cable, similar to a guitar cable. So the reason why I'm explaining you that is because this particular video is a guy who wants to change the voltage control system of these synths so it can talk to other machines. That's why those systems were there. He wanted to change that with a MIDI port, so he's making a modification to this old synth. And I mean, we don't really need to understand this or see it. I just wanted you to kind of feel how a synth look when you see it inside. So this is the MIDI kit, you know, that will change the voltage control unit for a MIDI unit. And yeah, there it is. And yeah, and just like you see, like he's explaining, like, oh, this is what this does, this is what it does. I mean, these are just the parts inside the synth. It's literally like a computer, basically. That's what it is. This is a Juno 6. So yeah, he's checking like, oh, this thing works, and I just want us to feel these things and to see how they are inside. All right, and then let's see if this let me go ahead. And this is another one. This is just another one. This is a Juno 6 repair. Yeah, I mean, again, we don't care so much, but I just wanted us to feel these things. And this guy has other synths there that are useful, that are cool. This is the Prophet. And okay, and so we arrived. That's kind of like it about basic history. I mean, what I wanted you to know about basic history is that we started monophonic not because we wanted. We continued polyphonic because we could. And then we're very happily making some music with synths nowadays that can make different voices. And also I wanted you to feel that initially synths were not exactly like a computer, and then they became like a computer. And nowadays, well, I mean, obviously synths became a piece of code, and that changed everything. Okay, so we're gonna go to Ableton Live to discuss a couple of things. And I installed a plugin here yesterday that I hope it works. Wait. I have the Melda one, but it's really crappy. Yeah, wait a second. I just want to see if I have a plugin that I'm gonna need. Tools, right here, the oscilloscope. But this guy, I was testing it and I really didn't like it. This is an oscilloscope, and an oscilloscope is a device that helps us to watch waveforms. Mm-hmm. Da? Da? Ah, yeah, that's super cool. Wow. Wow, that's super cool. That's super cool. Yeah, I would love to see that. Like later you can tell me. I'm gonna load here. I'm actually gonna load here before we continue. I'm gonna load the operator. And I just want to have. Thanks. Yeah, thanks. We can watch it. I want to have here this waveform, and I want to change it. I'm just making a test here before I start the next. Oh, that's good enough. I mean, yeah, that's good enough for what we need. Let me see this, and then if I add another one. Okay. And this one, just a moment. This one is not giving me a signal because if you figure it out, tell me. It's off. No, it's on. If you figure out why I don't have a sound, just tell me. I have it in the oscillator A, and I should have it in the oscillator B. Wait, let me just see this. Just give me a sec. C, D. Just don't know why I don't get. I see. I know why. It's because of this. It's because of this. Yeah, it's because of this. Yeah. So if I put them like this, then all of them will sound parallel. Okay, cool. Okay, I wanted to have a way to show you the waveforms and to discuss this. Okay, this is really cool view. This is a free plugin, by the way. The one you're seeing here. It's not all. Yeah, they have a Salt suite, but it's such a crappy company. I don't know. I'm super not interested in their plugins like at all. But and this is not a good oscilloscope. I know a lot better ones, but the one that I like is it's a 30. Where is this? Wait. What's up with our keyword? Just a moment. Sorry. Yeah. Yeah, I just need a second to calibrate this guy so we can see. I don't know if we can do this here. I will hope. And then let's increase the zoom. And further, can I see further? Yeah. But why does it look like a sawtooth? I just don't understand. This is like yesterday I was playing with this oscilloscope and like in here, at least you can see that it's a sine wave. But why is it showing me here a sawtooth? It really goes beyond me. but well, this is at least this is useful. This view that we have here. Yeah, no, we need one. Next lecture we will definitely have a better option. I already know where to find, but yes. This is gonna be cool. Okay, so sign for beat. Okay, I'm just checking out how good is this to what I want to show you before I triangle. Yeah, I mean that's close enough. Yeah, that's close. Yeah, and I want to see something like why he's here. Like I want to see the full. Wait, let me see if I. Oh no, this is maximum zoom. Okay, normalize. No. Yeah, there is a couple of things that I really want to show you, but this view doesn't allow me to do it. Ladna. Okay, I'm not gonna suffer for this. Let's just get this started. So, when we are gonna study synths, and in here I ask more the attention of everybody, of course, but especially those of you who don't know what we're gonna talk about. Okay, we are gonna have to understand several concepts. So this is a summary of those concepts. Okay. Basically, that machine that aliens gave me that can make any sound are really simple machines that just need a couple of parameters to create insane complexity. What are those parameters? Oscillator, we will discuss what is that. Low frequency oscillators, this is called LFO. And every time you see in a synth, you're gonna now open synths and you're gonna start seeing words that will become familiar to you. And every time you see that, it will always do that. It will always do the same. Let's look at this guy, for example. Like just quickly. If I grab a guy like this and you see it, in here it says oscillator. You see it? From there, maybe not. Do you see it? Yeah. And if I grab a guy like this, I see something else that says like, I'm gonna find here. If I don't find the word, because what I want to happen to you guys is that you look at every synth or every piece of gear in the world and you can operate it. Like you don't need to kind of like know this synth. You need to just know basic principles. So, okay, oscillators. I see one here. Great, check. Low frequency oscillators, SO, LFO. So in this particular case, maybe I would need to know a little bit more about it. I see some things that says here modulation, and that's connected with a low frequency oscillator. How do I know that? Let's read what I do this. Produce waveform used to modulate parameters. What do I mean by modulate parameters? Let me modulate my voice right now. I'm gonna modulate my voice. So, so my left hand became a thing that modulates my voice. And how does it do it? By changing the volume at a certain speed. So I don't know, if I do this, my left hand became a modulator. So it's really inconvenient to do this with the hand of a person. So why don't we have like an electrical signal that is changing the volume of something all the time, for example, and that can be a modulator. So you can, anything that you can do with your hand, that you can move a pot and make it react, make something react. And you can also make that same process with an electrical current that doesn't depend on a human pushing this thing and moving it. It's like an invisible hand tweaking knots. That's, you said it better than what I wanted to say. That's exactly what a oscillator or a low frequency oscillator is. Produce waveforms used to modulate parameters such as pitch, etc. Voltage control filters is like, imagine that inside your synth you put an EQ. Like literally it's an EQ. That's what it is. Envelope generator. We will come back to all these topics. Okay, I'm just making you a list so you know what we're gonna do. Envelope generators. Like, look, I can make an envelope with my left hand. So it's like, what's the attack? You want it to be a slow attack or a fast attack? Slow attack. Okay, so let's make an envelope for my voice. So it would be like, ooh. So I just made an attack, sustain, decay, and release. And then we have voltage controls amplifiers, which are things that just change the gain of the synth, like make it louder or quieter. That's all. That's all there is. You already know everything about synths. Congratulations. Like, that's all you need to know. So, no, and I really mean it when I say that's all you need to know. Because, well, I mean, that's not all you need to know, but that's a really, really good starter of the kind of things that you're going to need in order for you to master synths. Oscillators, low frequency oscillators, voltage control filters, envelope generators, voltage control amplifiers. So this flow that you're going to see here, this is a very simple synth that we're going to open right now. It's the Minimoog B5. And this is a very, very typical scheme of a synthesizer, of how it usually works. And you have to see it like a little Ableton Live, like a microscopic Ableton Live. That's the best way to see it. And so what do you have in Ableton Live? And your answer would be tracks. Great. Like you have tracks, right? And what happens to those tracks? And you say, they sound together in a stereo waveform. Great. That's amazing. So it's exactly the same. Like it's just like it's simpler than Ableton Live because it doesn't have that capacity, powerful, technological, I don't know, horizons. So what do I have here? Imagine track 1, track 2, and track 3. That's the best way to see it. And what is each track? Is the sound that is generated by an oscillator. And what is an oscillator? We're going to see it in a minute. It's a piece of equipment that produces sound, very simple waveform. And it's just like, imagine, like a chip. You have to see it like that. It is a chip that generates alternating current. And why does it work? Thanks God, or whatever you want to call the creator of the universe, for the fact that we can manipulate electricity and sound just like that. So what you have in a synth like this is track 1, track 2, track 3, and each of those tracks are called oscillators. Oscillator 1, oscillator 2, oscillator 3. So, and then what happens? Let's follow this flow. Oscillator 1 has a volume knob, just like you have like a volume knob, in volume fader in your Ableton. Oscillator 2 has a volume knob, oscillator 3 has a volume knob, and oscillator 1, 2, and 3 can be switched on and off. You see? On, off. So what does it mean? You can create a sound that has one component only, or 2, or 3 each, because you can add another component here, which is noise. It has a noise generator too. So before I go into explaining what are oscillators and how does this work, let's just directly open a synth and discuss it with the synth open. What do I have here? I have filters. You see, so I have a global parameters, I have oscillators, I have a mixer, I have an amplifier, an envelope to output, and then I have an output. So oscillator 1, I can change some things. I will discuss this when I open the synth of it, change the volume, switch it on and off, and then I can run it through an EQ, literally. And then I can just control the volume. So what do you have here? I have oscillator, here you are. I have low frequency oscillators. They are here, like here, kind of. This is a bit more intricate in the synth. In some synths it's more obvious. We have a voltage control filter. It's an EQ that is located here. We have an envelope generator. It's like a thing that makes attack, sustain, decay, and release, like here. We have voltage control amplifiers, which is a thing that makes it loud in the end. And yeah, and that's it. So let's open a synth, that same synth. And this crappy oscilloscope at least is going to help us a little bit. But let's open that same synth. So that synth, if you ever want to play with those synths, come to this computer. They're all installed here. The whole this is my personal, it's not from the school. The whole Arturia pack is installed here. So anytime you want to just play around with those synths, just come to this computer. Where would you find them? Arturia, and there you go. And so what are we going to use? The Minimoog Mini V3. So here we go. Let's open this. And this is what I care to discuss today. I just want us to start engaging with the principles of one synth, so we can start engaging with the principles of other synths. So if I place this, it's already a rich sound. It comes with the preset like that, and you see its waveform is like, I mean, it's a combination of several other waveforms that produce a rich and complex waveform. So when we want to create a sound, pay a lot of attention to me right now, because this is going to be, maybe the rest of the lecture was a bit washy and not understandable, but this is going to be really important. When you want to create a new sound, what you have to start with is to control, and this applies for a lot of things in audio engineering and music. When you start, you have to be able to produce silence. If you don't produce silence, it means that you're not under control of what you're trying to do. So if I play this and I want to silence it, can you guys tell me kind of what is your intuition tells me I should need to do? I want this thing to not produce sound. I want to touch a knob and it doesn't make a sound. turn off all the oscillators. Great, so it's like 1, 2, 3. No sound. I play the keyboards and there is no sound. And that's what I wanted, so I can know where are each one of the parts of this sound. So then I want to hear oscillator 1 alone. Okay, that's great. Look, that's oscillator 1, you see? And what waveform is it playing right now? It's a sawtooth. Now, if I change, remember our friend Wendy Carlos, it's a sawtooth. Like, it's a sawtooth. There you go. And then if I change it, this is kind of like a softer saw version. I don't know. I mean, I think that the Moog doesn't have exactly sine tones. This is a square wave. Precise. Yeah. Yeah, so, and this is a pulse wave. So these are different types of wave. You see, this is a triangular wave. This is a saw triangular wave. This is a sawtooth. This is a square. This is a wide rectangular. And this is a narrow rectangular. How do you make those waveforms? With sine tones, literally. So all you need is a generator of sine waves, and then you start summing them in a particular way. I'm going to show you this in a minute. And then you produce a, I mean, what I'm trying to tell you with this is like, this system inside, it doesn't have a microchip that can generate a square wave. It has just a microchip that can generate a sine tone, and then you sum a lot of those sine tones to produce a square wave. Do you understand that? I see a face there like, what? Do you understand that or not? Let me think about how can I flip this in another way that helps you to understand it. Okay, like an omelette is made of eggs, right? Like when I go to the shop, I buy eggs. I don't buy an omelette, right? And then I grab the eggs and I make an omelette. Okay, so eggs equals your basic element of, or your basic ingredient of making an omelette. Sine wave generator would look like this. It would be like, imagine like a little computer chip, let's say something like this, and then when you blast electricity into it, it produces a very steady current flow. That's a sine wave. So the synth I showed you has a little knobka that you can choose the type of waveform that you want. Like, oh, I want this to be a sine wave, I want this to be a square, I want this to be a triangle. You follow me there? I want this to be whatever, a pulse wave. Inside the synth, there are not like a microchip that creates a triangle and squares, and there is a sine tone generator that it's manipulated to create a different result. My example of the omelette was very bad, by the way. But you get the point now, right? I think. Yeah. Help me. Help me out.
Final result is a full dish.
Yeah.
Then sine waves are like ingredients.
Yes. The sine waves are ingredients.
You want to produce like a square wave, you add together.
Correct. Correct. And look, in what follows in the presentation that I built for you, it's like, okay, we are going to build together a square wave here. Like, so we're gonna together right now. We're gonna do it right now. Like, we're gonna build a sawtooth. We're gonna build a square wave and a triangle wave. And so you can see that these things are all coming from simple tones. And this is wonderful that we can create so much complexity with such simple things. Okay, but let's first, before we move there, let's first kind of like get a bit familiar with some device like this. So the other thing that I have here is a volume knob. So I can also turn off the oscillators, not by switching off the button of off, but just by turning the volume up. So, and I can also choose the first component of my synth, how much of this oscillator is going to have by mixing it. Now, this thing has one more sound generator, which is noise, you see? And it's not noise like noise, it's like noise, like really noise. Sorry for my bad joke, but yeah, it just wakes you up a little bit. So you can choose it between being pink or white. Okay, so that's cool. I mean, what would you do with this? I mean, it's just there, it's a useful resource. And you can ask me like, man, but why did they actually put that ugly noise there? And why didn't they put something more cool? Exactly. Yeah, I agree. I agree with you. I like how energetic you said it, and I agree with you. Noise is awesome. But the reason why I started this sentence is because I wanted you to remember that that's what was available in the 60s. I mean, was created in the 60s, and it's not like you could just go to China and buy go to a factory of microprocessors and get whatever you wanted. What was available was oscillators, and what's the name, and noise generators, and that's all. And all of these things were created for the military. Like, they were needed for other purposes. And then some people were like, let's just grab this thing. Okay, so let's continue watching at what we have here, kind of. So we have an oscillator here, and then I'm gonna follow the most simple procedures. So I'm gonna switch off this noise right now, and then I'm gonna show you that this is an EQ. Look. Oh wait, did you see? Like, it's literally just an EQ. What is the cutoff frequency? Well, let me open a real EQ here. I know that you guys saw lectures with Anatolia about synth. So far, we're in a good direction. Like, this is very different to what you saw with him. Am I correct? No? Like, you saw this? Because, I mean, I understand that you saw it in Ableton. I don't want to be so boring. How much? Like, I mean, I'm sorry that I don't know this, but it's just sometimes we cannot. A little bit. Okay. That's great. That's great. I understand. Do you feel? Have you ever sat down and opened a? I mean, not you. I mean, with a teacher. Have you opened a synth like this and discussed it like this? You did it with the Ableton synths. Cool. I just don't want to bore you. Like, if it's boring, just tell me. But great. This is just like a bit different than what Anatoly did, because I don't want to touch the Ableton synths at all. Well, I will actually, but just because they're useful. Okay. Anyways, sorry for that little pause. Let's continue. So, okay, what else do I have here? I can change the range of the oscillator. So that oscillator can be a high pitch, half of that high pitch, and then half. Do you know what are these numbers? They are pipe lengths on organs. It just comes from the organ world, because obviously, I mean, I can show you as yes, correct. Like, I mean, like this thing, it's a synth, literally. Like, I mean, this thing is a synth. I mean, it's just like a very, very particular synth, but it is a synth. It's just like each one of these are oscillators, literally. Yeah. These are oscillators, and I mean, and then this pipe is kind of like, imagine, I don't know, 2-meter pipe, 10-meter pipe. So the larger the pipe is, the lower the sound is going to be. So this is a transcribe from the era of super analog church pipe synths into the present. And so what you have here is like the inches of the pipe, and that tells you the octave. Now, because synths were made before the era of computers, sometimes the user interface is a little bit awkward. And you will have to pay attention to some little things that appear there that may be confusing at the beginning. Let me close this, because I feel that we cannot see so well. Just close a little bit this. Tak. Oi. Yeah, that's better, I think. That's a lot better. Okay, so there are some things that are not so obvious when you grab a synth, and you will develop instinct for this kind of things. You see, like, here it says like 2, 40, 8, 16, 32, low. they just like ran out of numbers or something, or whatever, or they just want to, it's not audible, or it's kind of like almost not, it's like so low. Let me just go up in octave. Yeah, and so it's something that you cannot even distinguish as a pitch. And now look, like when you, let me just remind me something here. And you see this guy has low and low mono. What I want to say is that, for example, sometimes it happens in synths that when you go under 32 inches, then that oscillator becomes something else. It stops working as an oscillator, and it starts working as a modulator, for example. And this is something that it's just about synths. It's kind of like made there to confuse you, but it's just like the user interface was different to how it is right now. But let's continue on the basic setup. So, okay, we have this. And I showed you that we have a synth. And now let's see this 1 second in a equalizer. I wanted to do that. Sounds, EQ, audio effects, equalizer, EQ8. So here we go. And let's open this here so we can see the visualizer. And now let me show you what happens if I close this. It would be better if I start cutting frequency. So yeah, I mean it's literally an EQ. And if I make something more that contains more harmonics, you see, like I'm just literally EQing them. And that's your famous dubstep movements there. It's literally a modulation of this. Now, you see, do you know what I mean by dubstep? This dubstep sound, wah, 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 wah. Yep, like everybody knows. You ladies know what I mean. Like that sound is made by grabbing an oscillator and modulating the equalizer on top of it. And what do I mean by modulating? Making it move. That's all. That word sounds like so fancy, like, oh, modulating. Oh my God. All I'm doing is just moving my hand and a pot. And then this thing obtains a very fancy name. But the thing is very simple. All you're doing when you're modulating is just moving something. Now, you are lazy and you don't want to do it yourself. Maybe you want to be playing a concert and be able to drink a beer. And then you want this thing to modulate without your hand moving there. Okay, great. That's why you think about a technology that can do it for you. So when I say modulate something, what I'm saying is just like changing it remotely, automatically, with some electrical process. So we can modulate everything in a synth. We can modulate the cutoff frequency. Do you understand that? We can modulate the cutoff frequency. How can we modulate the cutoff frequency? We will see it in the synth in a minute, but I can modulate it with my hand. And if I have it here in full, it means that the whole, like that you are listening to the whole waveform. You know, I'm not cutting anything. And this, my friends, is why this thing is called, like, it's kind of like a synth that adds up different waveforms and then you sculpt them by removing stuff from them with an EQ. So what else do I have here? I have a cutoff frequency. Every single synth in the world is going to have a place that says cutoff. Like, you will see it everywhere. And now you already know. You look at a synth and you're like, oh, look, that's an EQ. In every single synth in the world. Then there is another thing called filter emphasis. So look, if I grab an EQ and I do this, I'm making a little resonant peak with an EQ, right? And if I make it very narrow, now I get this resonant peak there. So the filter emphasis is exactly that. It's like, where is that peak? For example, this one is a subtractive peak. So it's kind of like cutting a bit. But it's like a bell. That's how you can see it. And the contour, let me see something here. Yeah. Yeah, let me just for being sure and not telling you bullshit, let me just check something here. Contour mini moog Arturia. Wait. Just to be sure, because I don't want to fuck it up and I just want to be sure. I just want to quickly search this. What is amount of contour? That's all I wanted. Okay, great. So later, when we are going to start to modulate this guy with an LFO is another oscillator. The contour will be the amount of modulation that happens to this cutoff frequency. So it's kind of like, imagine that I can modulate like this. Look, I can modulate like this, or I can modulate a lot more. Like, you see what I mean? Like, when I change the amount of contour, I will change the amount of the cutoff frequency that gets modulated. And then I have that thing is happening there. Yeah, with the amount of contour, precisely. If I put it in 0, there is no modulation of it. Wait, let me... Yeah. And I want to know where is this filter modulation is on. Ah, yeah, this is going to be connected to the attack sustain indicator release. Okay, for now, let's just leave it like this. And I have a filter emphasis. Here you go. That's more close to what I wanted. I had already modulation happening. So I have this like bell EQ. It's actually here. And that's what that is. If I change the octave, here's that. So to recap, this is an EQ, and this is a bell EQ. This is a cutoff, like a low pass, and this is a bell EQ. And the amount of contour is how much modulation will happen to these two guys. We will understand that a little bit later better. Okay, so what else do I have here? I have a volume knob, right? Where I can control how much is my output. And then the same thing applies to a second oscillator. If I switch on a second oscillator, now I have two oscillators here working now. Now let me just put this like this. And I can change the octave of the second oscillator. And I now have another knob here, which is a fine tuning of the oscillator too. So I can make now something like this. And then I can switch off anytime I want oscillator 2 and just have oscillator 1. Okay, cool. That's pretty cool. I don't want to explain all the parameters right now. You have just understood that I can just anytime in the world I want switch on off oscillators, that I can change the waveform of the oscillators, and that I can filter them with an EQ. Now, quickly, before we go back to our slides, by the way, I will take a little bit of our time after 12. I also have a lecture after. I'm really sorry for that, but we started a bit late and I don't like that. So I'll take a couple of minutes. I'm going to quickly open another synth, just a random one, quickly. And actually, let that be the Prophet 5 that I have it here, the Prophet. Here it is, Prophet 5. Okay, and so let's load this guy here. And now let's open it quickly and see like, oh my god, what is that? I don't understand anything. Oh no, wait a second. Leo told me that there is something called oscillator 1 and oscillator 2. And now I see that. And then I should expect, this is what you, every time you see a device, they are designed for you to know how to use them. They're not designed to confuse you. Everybody who makes a device, they want you to use them. And so there are sort of conventions that companies use across synth design and any design, plugin design, everything, that will help you to understand what you're doing. So you see, Leo told me that there is 2 oscillators and that there is a mixer where I can blend them. So, oh, great, SMA3. Oscillator 1 is off, oscillator 2 is off. And also Leo told me that I need to achieve silence when I start. There you go. I have no silence. So now what do I have here? I have oscillator 1. And what happens with oscillator 1? I can change the frequency of oscillator 1. It's the same as I showed you right now. Exactly. In the Moog organ was shown in pipe values, and in here is shown like in octave. You see, semitones from the actual note that you were playing. Like, let's say like a La4, like a A4 is 440 hertz. So if I start on an A4 and I move 1 semitone down, 2 semitones down, or whatever, or 2 octaves down, or 1 octave. And now in here, you see, like let's open in parallel this synth that we already learned, that we already have experience with. Let me just get out of here and open another mini track, and I'm gonna open in parallel the mini Moog together with this guy, and let's just put it here. And so in parallel with these 2 guys, I'm going to open them, and you see like what do we had here? We had the range, so we have here the frequency. Let me just leave this one on. And then in here, remember, I could change the type of waveform that I was engaging with. Okay, in here I have just 2 options. I don't have more than 2 options. I have either this one. If I select unselected, there is no sound now because I'm not selecting any waveform. I have a triangle wave or a square wave. And now, this thing that it's called pulse width will appear a lot everywhere. And this is, you see, like let's see how this thing looks in the oscilloscope. If that crappy oscilloscope can help us a little bit. Wait, so let me just drop here the oscilloscope in plugins. Oscilloscope, os. Yeah, oscilloscope, here it is. So let me just drop it. Oh no, that's in the mini, sorry. Let me just drop it in the Prophet. And let's have a look at our oscilloscope and see how this looks like. If I make a zoom in. Let me just try to neutralize this. This guy, I think, has like a really simple starting point. Wait. Wait. No. No, okay, it doesn't. Okay, хорошо. I just wanted it to be more simple than what it is right now. It's such a crappy oscillator, man. Oscilloscope. I'm so disappointed. Yeah, and there are a lot of functions switched on right now. Wait, let me just get this off. I want a very simple thing that it's just very stupidly simple. So let me see, the cutoff is here. The attack. There is some other stuff happening here, like maybe a delay. Sometimes they have more than they're showing. Yeah. You see, it has reverb. And sometimes these plugins. Right bottom. Here? Yeah. I don't know. I just want it to be extremely simple. Yeah. And you see, like in here, there are modulations. Keyboard. Yeah. That's it. Okay, so, and let me turn this volume up a bit. I wanted to show you the pulse width and what that is. Yeah, there you can see it. So imagine a waveform, because this is another concept that will appear a lot, and that's why I'm insisting on it. Imagine a waveform that is a square wave. So a square wave is basically an on and off event. It's literally an on and off event. It's like on and off. There is not like a slope after the off. It's just like either on or either off. No middle ground. Now, whenever you see in a synth the word pulse, sometimes it's P width. Sounds like a name of a rapper, by the way. Like P width. Yeah. Sometimes it's P width, or sometimes some Harry Potter name too. It also feels like some Harry Potter name. So P width or pulse width. And what that is you see, like a square wave is an on and off signal. How much time do we spend in on? Imagine that this is a cycle of the waveform, like beginning and end, and then another cycle starts. So it looks like this. So how much time do we spend on the on part of the signal? That's the width of the pulse. Do you understand that? Make sense? Okay, cool. I hope yes. I don't feel that I explained it well, but now if I change the pulse width, what happens? You look at this. You see, like the oscillator is like there is a very small instance of on going on, and if I start expanding it, I just increase the width of the pulse. Okay, so I have oscillator 1, and I can change it from square wave to a sine tone. And I have an oscillator 2 that this happens a lot. It gives me 3 options now. Not only 2, excuse me. So I have here, let me see the frequency. The volume is very quiet. By the way, when I was before playing, it was not in total silence. I'm curious now to see. Hold on. Okay, not such a big difference. Okay, let's see the oscillator too. So it can be a triangle wave, sorry, a sawtooth wave or a triangle wave, or both at the same time. You see? Or it can be a square wave. And I see, oh, look, pulse width is there again. So what does it do? It just changes the width of the pulse. Great. Great. And then I can fine tune it. This one doesn't allow me to fine tune it. And I can also change the frequency. Okay, so you have seen two synths already, and you have seen that you can kind of get around through it quite quickly. You see oscillator 1, oscillator 2, a mixer, and a filter, and it's the same filter we just discussed. It's like, okay, if I grab this, this is an EQ, basically. And so, and then I have a resonance frequency. It's that peak, like an EQ. And then I have the envelope amount, which we'll discuss in the next lecture. And then, of course, all of synths have, let's go back to our mini-MOOC for a second. All synths have another module, which is going to be our attack, sustain, decay, and release, or an envelope. So, am I back? Wait. So, let me just, this one has a really simple, one oscillator. There it is. There it is. So, where are we? Yeah, I wanted to modify, you see, loudness contour. So I'm changing how fast the sound starts to appear with the attack. When I remove the hand from the keyboard, there is silence. Unless I change the sustain, the decay time. So now when I release my hand, it just fades away slowly. And that's it. And I think for today, that's a really good place to stop. Now, what are we going to do next week? When we come next week, we're going to start right away on the oscillators, and we're going to try to build a sawtooth wave right from the start. And then we're going to discuss something called syncing, which is really important for synths. And yeah, and then I really want us to start slowly. By the way, we will be on synths for a long time, okay? So bear with me. And if you, I don't know if this is bothersome or boring, just tell me. But it's going to be really like 6 weeks or something. So it's going to be a long journey. I think it's worth it. It's what we need to be doing. So we're going to also be studying synths. Like, for example, let's have a listen to how the mini-MOOC sounds, because you need to be able to, as a producer, we will, like in our synth lectures, we will sometimes open this and listen to it and then give some characteristics to it. Because the other thing that you need to do as a musician, as a music producer, is like, you know, if Red Hot Chili Peppers come to me and tell me, let's make an album, I would be like, fuck yeah, let's go. And the second thing I would think was, I need a Fender Stratocaster right now. I will not think that I need a Gibson Les Paul. Like, these are different guitars. So you as a producer need to know, like, that's more a MOOC thing than a Prophet 5 thing. Like, you need to be able to identify these synths, to be able to know what are their voices, how they sound, what sounds they're produced. So you can actually be able to understand which synth you need and when. Because not all synths are the same, and they're really different instruments. They have different timbre, different reactions, different functions. And my goal with this course is to expand your palette of music making in a way that you can just know which synths you need for what, etc. All right, thanks. Let's see each other next week for now. And thanks for your attention. And I hope it was useful for you. So I will put these things in Google Classroom a bit later, like not immediately now, but I just wanted you to know that this is going to happen. And that by the end, you need to make a little bit of a 4-song release. We will discuss that later. So thanks a lot, friends. Attendance, let's do it right now. Let's do it. And I also need to update. Natalia sent me last week the Positischeimes, and I haven't updated it, so let's just do it right now. Brom, per course. I'm so excited, guys, about, I mean, you guys are in a great situation because I mean, the guys who are in third year right now, they are seeing all the lectures for the first time, and you guys will see them. I mean, I really want to teach you next year. Like the materials I have ready for you next year are so amazing. Like, and I want to tell you all right now. Like, and sometimes I see students in the hallways, and I'm like, I'll wait a year. I'll wait a year. I'll tell you next year. Just really great materials I have prepared for the future. Like, thank you, Nat. Yeah, I'm really excited about this. What's gonna come? Okay, so okay, so we are here, and it's like I haven't done this in the whole semester. So yeah, I calculated the semester total, and that's how it was. And I, by the way, just so you know, when I calculated that, I deleted the instances where I didn't took Pasishemas. So I did this like a month ago or something. It's just so you know. Okay, if you have any discrepancies or you don't agree, just tell me and I'll fix it. So today is 15th of March, and last week was February, March. So today's 15th. Last week was 8th, and you're right. You're right. The week before, on the 1st of March, we had this, and Natalia sent me the thing. So let's see it. So who is here? Anton is here. Tatiana is not here. Barbara is not here. Alexei. Kirill. No. Fadej here. Kistirova, yes. Liana is here. Ah, sorry, I missed it. Katerina, yes. No. Natalia is here. Misha was online, I saw him. Sergey is not here. So Palina was not here. Sofia. And Daria. Did I miss somebody? No? Okay, great. And now let me just put the one that Natalia sent me right away so I don't forget. Here's Nata. Thank you, Nata, so much. So it was Anton. Up here. Anton. Let me do this. 1, 2, 3, 4, 5 below Anton. 1, 2, 3, 4, 5 below Anton. Then no, then 1, 2, 3. No, then 1, 2, 3. Then no, no, yes, yes. No, no, yes, yes. No, no, yes, yes. Thank you. No, no, yes, yes. Thanks. Okay, that's all. That's done. Thank you, guys. I have done attendance for all March already. Amazing. And this is March. 15th of March. Okay. Yeah. Which one? You cannot stop buying synths?